I noticed that we're on meeting 196 and we'll hit um, meeting 200 in January in the new year, which is interesting. We usually, every 50 meetings, have done something like an in-person meeting. I'm going to have to see whether I can attend an in-person meeting in January. There is a small possibility, and maybe we'll try to meet together in a room and have some cupcakes or something fun like that and pass out some hex stickers. But I would like to do something fun for that meeting. We will also transmit it online. And I'll have to think of the topic that we want for that. Still not updating. Let's just give it another minute before I begin. If it doesn't update and we're having problems, I can just drop the link from the GitHub. In fact, I'm just going to check the GitHub and see what that looks like. Not sure why it's misbehaving today. My internet is going slow, so maybe it's misbehaving because of that. Updated 2 minutes ago, so it should be showing up. It's just going slow today. All right, there we go. All right, so for everybody that's joined, you must have been sitting there clicking refresh. I do that all the time. It's a portion of my life. It's embarrassing. I do the same thing. Thank you. All right, so that's the link if you want to follow along. I'm going to go through some slides first, and then I've got a data set we're going to use as a test bed for the AI I'm going to demonstrate today. And and then there are a few files on the GitHub repo. If you don't want to download you have to log in to download these data. They're from a website called Kaggle. If you haven't heard of Kaggle, it's kind of a fun website. It's for data science stuff, and there are lots of free data sets on there, and I mean all kinds of data sets, everything from more scientific things to agriculture productivity data sets, to experiments from normal old scientists, to the one that I'm going to use for this exercise, which is completely different. It's a car price prediction data set, and there are many, many versions of all sorts of data sets. And then I've got an R script that I set up that we probably won't use it very much today. And then I've got a little text document with just a few very simple prompts I'm going to use on this AI. And the slides, if you want to follow along, are on Canva, my preferred slide platform these days. And so without further ado, here we go. Now, I was going to talk about a tool that that Google has been developing for a few years called Notebook LM. And it's put out there as a research tool for serious scientists and other interesting people. I've used Notebook LM in a number of experiments. We may have even looked at it once in here in the past. And once I started thinking about what I wanted to do today, I realized there was one AI tool that I haven't tried yet, which is specifically for data analysis, statistical data analysis, and that's called Julius AI. And I haven't tested it very much. I did test it when it first came out and was being advertised, and to be perfectly honest, I wasn't very impressed. But that was a bit more than a year ago, so I have lots of thoughts about what I expect from it. I haven't actually tested this latest version of it, so I thought we would do that together. And I'll give you my thoughts. I'll give you what I think tools like this, as they exist now and as they may develop in the future, will mean for scientists like yourself, and even for statisticians themselves. So let's go. So what we're going to do is I'm going to start off with an overview of several kinds of AI tools and kind of compare and contrast them. I'm trying to organize my own thoughts about how AI tools are developing. And somebody made the comment a couple of times in the past couple of meetings in here that um, some of the large language models that people are using, the popular ones, they cost money. And somebody mentioned that the university has started paying for Microsoft Copilot. That's pretty good because to use Microsoft Copilot embedded in Word and Excel um, and other places, it costs money. So it's nice that the university is paying a little bit for that. So anyway, I'm going to comment on the state of play and some different kinds of products, including GitHub Copilot and others like ChatGPT. And I'm going to compare that to Notebook LM and Julius AI for doing statistical data analysis and other things. I've been trying to, I think stock images are hilarious. So I'm just using this as a personal joke. I'll try to change the funny picture every once in a while. Okay. So this is a table that compares three kinds of AI products that we're all using products like these, and we'll continue to use them more and more in our professional lives and probably for fun as well in the future. We've all used general LLMs, mostly large language models, that is. And the purpose of these is to be a catch-all, do-all general answer machine. So you can, if you're thinking about analysis, most large language models, and I mean the big ones, I've put the couple of the biggest ones, Claude and ChatGPT. ChatGPT is the most popular one, I would say. Um, these are, I should say, ChatGPT um, is a foundation model. And I put that in quotes, and let me tell you what I mean by that is that a company called OpenAI, it's a little ironic because their name is OpenAI, but they're completely closed. It's not open at all. They commercialized the original ChatGPT 3.5 was the first really big one, and it's been around 3 years ago now when they released that. And we're up to a little bit more than ChatGPT 5 now, and they're coming out with versions quite frequently. And these these code platforms have been trained specifically for a particular product, and we tend to interact with them through a chat interface online. We don't interact with them through code at all. But there are alternatives, and I'm going to ask the question in a little while whether anybody knows what they think the best foundation LLM or any AI that they use is. What do you think the best is? But you can think about that until I get to that part. Claude is one of the big competitors for OpenAI's ChatGPT. Claude is a foundation model, and it was created by the company Anthropic. It's also a closed model. And there are other alternatives out there. Some of them are pretty good, and I'll show you a league table, the most popular internationally accepted league table for how good these models are in a second, and you can kind of compare these two models and a few others on the top 10 lines or so that I put in there. So most of these foundation models, they can write and execute code. What do I mean by executing code? That means that you can ask them to write Python code to analyze your data set, and they will write the code and run the code and show you the output. You can ask them to write R code and run it to analyze your data, and most of them will write R code and run it and produce the results for you. We had a little demo of that a few weeks ago. You can also ask, if you're not an expert or you're learning, you're building your tool set, you can ask for very detailed explanations or very terse, brief explanations. And you can also upload various file types. You can upload Excel files, comma separated values files, Google Docs. A lot of them are becoming very flexible and will accept multiple inputs. Picture files, you can even copy and paste, which is very convenient, at least in Claude and ChatGPT. They're not all exactly the same. Notebook LM is not a foundation model. It is a product. And I want to make a distinction today and going forward when we talk about these things between foundation models like Claude and ChatGPT versus products that are made by companies. Now, this product, Notebook LM, happens to have been made by Google, and they have their own foundation model. Does anyone know what the Google foundation model is without Googling the Google foundation model? Does anybody know what it's called? The Google AI foundation model. Has anybody heard of it? Heard about it in the news at all? Gemini. Sure is. Femi, it's great to see you. Welcome. We'll talk soon. Yes, Juliana too. Yes, it's Gemini. And Notebook LM is a product based on Gemini. Julius AI is also a product that can draw on several foundation models. Now, does it draw on Gemini? I don't know. And it's one of the things about Julius I noticed is that it keeps a veil between the user and what's actually happening underneath the skin, which is the purpose of a tool like Julius. And Copilot, I'll just mention it's not on my little table here, can use a number of different models, but OpenAI's ChatGPT-5 is one of the main ones, one of the versions of ChatGPT-5. Anyway, Notebook LM is touted to provide research synthesis based on documents that you upload. And it can do a couple of neat tricks. I've played with Notebook LM and it's very fun. If you haven't played with it, go play with it. I urge you to. It is so fun. One of the tricks you can do is you can upload a scientific paper that's a PDF and ask for a one-page summary of it with bullet points. And it is really, really good at doing that. Now, that's not that fun. That's just okay. And most of the other models can do that too. But here's something that the other models, the other products do not do. It's just a party trick that Notebook LM really made a big splash in the news when it came out with this, is you can upload that same PDF and you can say, Notebook LM, make me a podcast discussing the main points of this paper, is about 10 minutes long. And sure enough, the multimodal models underlying Notebook LM will create an audio file of two people discussing the paper, just like they're non-scientists. And you can ask them to pitch it for experts, or you can ask them to pitch it for the average person in the shopping mall. Anyway, Notebook LM, that's a bit of a gimmick of Notebook LM, but it is a very, very powerful tool. And what I suspect is that Google's products, I'll reveal more in a few slides why I think this, but I suspect that Google's products will become more and more prominent relative to ChatGPT and some of the others. Julius AI is purpose-built for data analysis, and it really is aimed at, I suspect it's built and mainly aimed for non-experts, definitely non-statisticians, but scientists that are early in their career and are really just beginning their learning process. And it uses a chat interface rather than a code interface. And one of the criticisms that I've seen levied at Julius AI, which I found in my very limited experimentation before today wasn't true, was that people criticized the fact that it would just run code and it was opaque and non-reproducible. You couldn't do it, but I'm going to try to coax it today to also give us the code so we can document the analysis we do. I asked you what you thought the best AI is. Does anybody have an idea of what you think the best AI foundation model or tool is. If you have a favorite one that you use, um, put it in the chat. I'd love to see what you guys are using. Does anybody have an idea for what people think the best is? Just drop it in the chat if anybody has any thoughts on it. You can guess if you want. That's fine. ChatGPT is a perfectly sound suggestion. The short answer is Grok. Okay, that's interesting. The short answer is that the all of the companies are working on these foundation models nonstop, and when when they reach a threshold to release a new version of their existing gold standard model. Now, DeepSeek. Now that is a very dank suggestion. Are you using DeepSeek locally? Are you using it online? Probably online. I love DeepSeek as well. That's a very interesting suggestion. Gemini and Colab, yeah, okay, all right. So everybody is. We've mentioned a few of them. We've mentioned a lot of the real big ones. Um, DeepSeek is real interesting. I'll allow myself to digress because it's completely open. You can download it and run it locally in case you have sensitive data, and a fairly beefy laptop or computer to run it on. But you can download versions of it, small ones included, to run local. That's a very interesting one. It's a very interesting one. Anyway, the best AI. It changes all the time. What people think when they measure how well they perform. How do they measure that? Well, there's a site that, if you're interested in this sort of thing, that's called the LM Arena, lmarena.ai, and we can go to the leaderboard. I'm not going to take the time today to do it. I don't want to use up all of our time where we can play in Julius. But if you squint, you can probably just about see that about 2 weeks ago, Google Gemini 3 came out, and the Google CEO was going around the podcasts and in the newspaper, and it has absolutely swept every category for performance. So there's an overall column. There's giving hard prompts to solve, and now there are standards for what a hard prompt is, and the same standard is applied to different versions of different models. Coding, math, creative writing, following instructions, longer questions, longer queries, multi-turn tasks, and there are other categories here. So we can see the ranks at the moment are that ChatGPT 5.1 High, that's the really difficult name for ChatGPT's best model, is fifth down on the leaderboard. How much is there in this? Well, 5-10% usually separates the top 3 or 5 from the rest, and then it does get steeper after that. But there is a span of about usually about 5 to 10% in the top 5. I've noticed Grok 4.1, the Elon Musk's XAI model, is considered second best at the moment, and Claude Opus 4.5, which is the one that I use day to day for statistical stuff and other fun stuff, is third. Okay. Of course, there's some ties. So for coding and math, there's nothing between Claude, Grok, and Gemini. But for harder prompts, multi-turn prompts, and creative writing, Gemini has dominated everything, and it was a pretty big jump by the standard. Anyway, if you're interested in this changes all the time. If we were to scroll down, DeepSeek was very high on this when it came out. It's probably lost 10%, so it won't be much further before these earlier Claude models, and you can see how it changes. I'm not going to go through these in a lot of detail, but if you're interested in this, there's a comparison. I did use AI to help generate these tables with some very specific prompts. about data analysis, in particular power analysis, doing regression modeling and things like that. And it turns out that if you want to do this kind of stuff, the general foundation models are pretty good. They can run code. Um, they can do statsy stuff. They can make visualizations, do power analysis, do regression, and all sorts of non-parametric statistics. They're great at doing it. You need to be pretty specific with your prompt if you're a scientist and you've collected data for a particular reason, but they're very competent these days. Interpreting figures from papers. This is a good one that I want to test. Maybe we'll test this next week to extract effect sizes from published figures. I haven't really tested that in earnest yet, and I would love to do that. Notebook LM. No, it's made for other things. It can actually, in the Google's AI Studio that is linked to Notebook LM, you can do some data analysis. I probably should have put the AI Studio here instead of Notebook LM, which is a different Google product. One of the things I find confusing about the Google family of products is that there are so many, and it's a bit confusing to figure out what their focus is. So anyway, for data analysis, it turns out that Notebook LM is not very good. It misses a few features that I thought it did have. For example, I thought it did have a vision feature, and I thought it could run code, but that's AI Studio that does that. And that's why I decided not to cover Notebook LM today. Now, Julius is very different. It's actually made to do statistical data analysis. Can it explain statistical concepts? It's good rather than excellent, according to reviews. Can it synthesize lots of papers? Well, that's where Notebook LM excels. If you have a body of work and you want to statistically analyze the results in 10 or up to 50 PDF papers, that's where you want Notebook LM, but you really can't do that in Julius, and maybe even the foundation models would struggle. Julius can run R and Python, and I suspect it'll do just fine to output the R code we ask it for today. It's made to be more automatic, and I think for a base beginner, Julius, from what I expect here, would be pretty easy to get started with. So one of the points, so that's, this summarizes my thoughts on Julius AI. It's should be quick and easy for data analysis for non-statisticians. It can do advanced analysis. Anything that R can do, in theory, Julius AI should be able to do, Python as well. One comment I wanted to make is the free use, because all of this stuff costs money. With the exception of the Google products, which you have really, really generous free allotment to use things. We'll look at the pricing for Julius in a second. I think it's pretty stingy, the free use for Julius. I wanted to say a little bit how it works. I have already mentioned a little bit that there's a large language model foundation model that underlies Julius AI interface, which is just a chat interface. It's a web page. It's a little bit fancier, and there's more to it, as we'll see in a second, than something like ChatGPT or DeepSeek. And part of the reason for that is it has ways for you to easily upload files, I think more easily than even ChatGPT, which it's very easy in ChatGPT 2 or also to do. It also allows you to choose the coding environment, which I haven't really seen in foundation model products before. So Julius AI, I suspect, will get better in the sense that the interface will be refined and the foundation models will be kept up to date. But these companies, especially these products, if you're not choosing your foundation model, when I showed you the picture of the leaderboard, you should be aware that all of these companies have different versions of their flagship model at any given point in time. There'll be a gold standard foundation model, there'll be a version of that that does what they call deep thinking, that takes longer to answer, but in theory will do more research and check itself and evaluate whether it's saying the right thing or not. And then they'll have several versions that are lighter versions. They won't be quite as good, but they'll be faster and much cheaper. And I suspect Julius AI, like all product, every product is going to be like this. Every product, AI product, including Copilot, Julius AI, Perplexity, if you've heard of that or have used that, all of these will balance the good stuff that you get, that you ask for through their interface with the price that the company has to pay for the use of the compute time for those foundation models. I'm not going to say anything more about that now, but that's a thing that's specific to these product models. If you're not choosing your foundation model with intent, then they're going to choose the cheapest ones for them that's going to minimally satisfy your query. There's another thing I want to say about Julius AI. The last time we looked at stats and AI in here, I showed you my way of constructing a file that had a pretty detailed prompt, and I showed you how I tested that prompt, and by naming the environment and then asking the environment, what's your name, just to make sure it was using my instructions for every query. So I have a number of these little tricks that I've developed that I use regularly and like. Julius AI will also have prompts behind the scenes. With my prompts, if I'm getting some results that I don't like, I have full power to control my prompts. You only have limited power to control your prompts with Julius. You can really, on the free one especially, you can only offer fairly limited length prompts for context. Not really going to spend time on the user experience table here. I'll let you look at that. I want to get onto it. I do want to look at the pricing and how stingy Julius is. This is a bit standard. You get almost nothing for free. So we can only do 15 messages. I think I've designed just 5 prompts for our data set today. If you pay a bit, this is about the same price as all of the LLMs if you're paying for them. You get quite a bit more. You could, you could do a handful of messages every day for the month, and then it would reset the next side. They have plus models, and they have notebooks. So the notebooks are opaque, and they'll give you the cheapest model possible. The plus models, they would allow you to choose, let's say, something like ChatGPT 5. Now, I haven't paid. I was tempted to pay for a month of Julius AI for today to try it out, but I thought we'll try it out for free, and if it's interesting enough, I'll consider doing that for a harder test in the future. But I suspect you'd be able to pick Claude 4.5, possibly Gemini 3, definitely OpenAI's 5 or 5.1 models. The thing I've noticed, Cursor, the little tool I showed you before, is also a product. It's a coding environment that has AI connection built into it, and it works really, really well. And I really like it. It allows me to access something similar to this, and I can access 100 foundation models. And if I want to access the very newest ones, then there is a limit. But you can always, they invite you, like every product, to pay a bit more if you really want it. Okay, so you get some other things. You're limited by RAM in the free account. That doesn't really matter unless you're doing pretty big data sets. And I suspect if you're doing data sets that can't fit inside 2 gigs of RAM, you should be paying anyway. You can connect to your Google Drive if you like Google, and there are different file storage formats, and it just ramps up from there. Okay, of course they recommend the most expensive one. So what we're going to do is we're going to go to Julius AI and the chat interface. I'm going to load up the R environment, and I'm going to show you the data sets, and we're just going to look at that briefly, and then we're just going to see what we get. for the rest of the time. Now, if you if you want to follow along, you can just download these files from GitHub. If you go into the data folder, there's a comma separated values file, and there's a data dictionary. We're just going to briefly look in those. I've got an R file that doesn't have any real code in it. It's just set up. And then I have a very, very simple text file that's got prompts. So I've already got that downloaded locally here. First thing I want to do is just look at the data. Now, the idea for this data, I'm just going to focus in on a subsection of it. They say the idea for this data set is that there is a car company that wants to move into the American market. And they've amassed this data set that has a number of variables. We'll look at some of them in a second, that have lots of different predictor variables to predict the price in the American market, and specifically the factors in the American market that can be used to predict that price. So they want to price their own product. That's the motivation for this data set. Is this a real data set? I don't think so. It might be. But you can see if it is a real data set, it's an older data set. They have all sorts of different makes. If you don't recognize some of these, they're the North American names for some of these. If we scroll across the top and look at some of the variable names, they have fuel type, aspiration. They have how many doors, the car body type, what the drivetrain is like, four-wheel drive versus two-wheel, where the engine is located, the general dimensions, width, height, weight, engine type, how many cylinders it's got. Let's see how big this number goes up to. I guess there'll be some 8-cylinder cars in America. Get beat up in some places, like where I grew up, if you didn't have 8 cylinders. The engine size, fuel system, we're going. So 26 variables, and then finally the price in good old US dollars. Okay, the mileage. Look how low that mileage is. It's just funny, sort of. All right, so if we just kind of close that, I don't need to save it. We can just open the data dictionary for a second. It's somewhat inconveniently in a different file, and it's just got, just exactly like we would expect a data dictionary to do. And I've just gone through it, but, it's there if you're interested in looking at it. Okay, so now I want to look at the prompts that I've done and just kind of give you my vision for what we're going to do. I've given a link if you want to go and read about the Kaggle data set. That's probably worth doing if you want to recreate this in your own time later. And then with the idea that, I might want to use this for my own data. From the Kaggle webpage, the goals that are derived from the data would be to identify the variables that significantly predict the price of a car, and then to evaluate how well those variables describe the price of the car. We're not going to stick to those. We're not going to try to emulate those very much. And I've got some very simple prompts we're just going to test. I haven't run these yet, but describe the data set and return some insightful summary metrics. In fact, I was scared to run them because I knew I only had 15 goes, and I didn't want to get carried away and use need 8. So I wanted to leave some in reserve in case we want to do some extra ones today. Remove columns that are irrelevant to regression, because there might be a couple. We'll see what it comes up with. Conduct the linear regression analysis with price as the dependent variable for prediction. Create a ggplot2 scatter plot relating price and engine size. Add a linear regression line. And finally, see if we can get the code back. Return one code box with relevant R code and explanatory comments for the entire project. This should be suitable for me to copy and paste into RStudio. Okay, so we're going to try this. And if we just go to Julius AI, /chat. Now I logged in earlier. It does recognize me. That's good. What do I want to analyze today? Okay, good. So one of the things that I wanted to show is that up here at the top, this interface is nice, and it's not the same as ChatGPT or some of the other foundation models. It reminds me of Google Colaboratory, and it reminds me of live Python, IPython notebook sites like Replit or some other sites, because it demonstrates that it's connected to a so-called runtime environment. So it's connected to a virtual computer in the cloud, and also it gives me a choice of which runtime I want. I'm just going to choose R. It doesn't tell me the version. Now that's not ideal that it doesn't tell me the version. Because if I want to really replicate this and document an analysis like a scientist would want to, I really would need to know the R version. So I'm guessing this is a modern R version. Hopefully it's version 5. I don't know what lean Python means, but we could probably read about it if we really wanted to. And then it's giving me a gamified thing over here where it's asking me to connect my data, run an analysis, and calibrate Julius. And I don't know what calibrating Julius means, but the first thing I'm going to do is connect my data. And it looks like it's inviting me to spend some money before I've even put one command in. But what I think I can do from some instructions that I read is I think that I can just drag my data over here. Julius is analyzing. I'm going to cuts off the word analyzing, even though so it's uploaded it. It refers to it as a spreadsheet. It's given me a little bit of a trying to find the sweet spot. I think this is as big as I can get the text. Yell if the visuals are not working, and I'll try to do a little bit more to fix it. Maybe that's a little bit better. I'm going to just pull this over a little bit. Try to make that a little bit bigger. There we go. So it's given me some preliminary notes. I did not ask for preliminary notes, but I like that it's done this. File contains 20 cars. Is that right? I thought there were more cars than that. In fact, I'm almost sure there are. Let's just have a look at that. So it's already gone off the rails. Certainly has a lot more than 20 rows. It's 206. With 26 columns. It can be used to explore relationships, summarize typical characteristics, etc. Okay, so that's almost not helpful. It's so simple. If I scroll down, it has only given me some of the rows. Can you please read in all of the rows? How many are there? 205. Oh my goodness, this is super annoying. Okay. So that seems to have done something. Looks like it still might be thinking. There we go. I've loaded the file and confirmed it has 205 rows. Here's the head. Great. So it ran some R code to give us the header of the table. Okay. All right. Had a little wobble to start off with, but let's continue. Let's first describe the data set and return some insightful summary statistics. I'm also interested to see how long the prompting takes. I'm already being incredibly annoyed, even though it's subtle. by all the pop-ups inviting me to spend money when I've only been on the site for about 5 minutes. Let's go up and see everything that it just gave us. So just going to close that for now. Okay, so it's written some code, which is nice. It's explained the code. It's got something that I'm not sure about. It's got a high-level description, identifying what is in the data set. This is a bit like what I call weighing the pig. It's called the summary function to give us just a numerical summary. This is usually pretty unuseful, but sometimes it's interesting to look at just to make sure there's nothing weird. It's given us a numeric summary with a lot of summary stats. This is also fairly unuseful depending on what you want to do, but for a statistical analysis, usually we wouldn't do that, certainly not with a summary table. It's allowed us to download that summary table, which is, not bad. It's made a histogram. Let's just have a peek at that. It would be nice to display that in line. So it's just giving us a frequency histogram, and it's not surprising that it's skewed. Most everything is common and cheap, and then a few real expensive ones are rare. Okay. So it's done a correlation matrix with some select ones, and it's highlighted strong positive and some strong negative correlations with price. So the higher the price, the lower the highway miles per gallon. Not surprising. Simple visual insight. Just having a peek at that. I wish it would display those in line. Okay, it's got the cone of terror that we don't like to see that shows heteroscedasticity. But we'll deal with that. We'll see if Julius can deal with that. It's horsepower versus price. And then it gives us some suggestions at the bottom. For some reason, it's not quite letting me read them. Oh, that's a bit weird. So the interface is a bit weird. Maybe it doesn't like Google Chrome. Okay, and it's made some data frames that I can inspect. Okay, so we're just getting started. And now what I want to do is to conduct linear regression with price as the dependent variable. Actually, first, I wanted to remove the columns that are irrelevant. Let's see what it comes up with. A novelty about this is I don't know of another product AI made just for statistical analysis. And this company, okay, let's just have a look. Already created the data frame. Okay. Okay. The only columns removed so far are the car ID and the car name. Those are unique identifiers that would be irrelevant. So I agree. I want to see if this one takes a while. So I'm going to go ahead and do it while we talk. I don't want to run out of time completely. So I'm going to do that, and I'll talk while it's thinking. I like that it's producing some code. It's pretty good. What I've noticed in other, first pass linear regression, it's still going quite a lot. That was very fast. So I'm pretty impressed that it did that. Wow, look at all of those ones. We'll come back and look at them in a second. Okay, so what I expected it to do here was to make a big linear model. I wondered if it would comment on whether it was appropriate to use all of the variables, which let me now reveal to you it isn't. But I didn't prompt it. It's given us the code, which I like, code explanation. So it looks like we can download that. This looks like it's just comments in the like would be in a script. Model that was fit, dropped a few variables, treated a few as categories, of course. Fit the linear model, and it gives us the spec. It's good. So it actually didn't use all of the variables, that is impressive if that's true. 16 variables. Okay, I like that actually. I think why the regression table is so long is probably because they did a summary for a linear model. That's exactly what they've done. And this is a contrast table as opposed to a main effects ANOVA table. We've talked about that before. I'm not going to go into technical details, but if you have engine drive like these that I've highlighted, there will be all-wheel drive, front-wheel drive, and rear-wheel drive. And these estimates will be relative to the default baseline, which in this case is four-wheel drive. So the price, this is the estimate that affects price relative to one of the levels. So that's why there are so many rows. Looks like a lot of them are significant, but not all of them. Door number, not relevant. Some, like the engine type, highly significant, at least one of the levels. Engine size, highly significant. Stroke of the cylinders, peak RPM. Okay. All right, so that's exactly what I asked it for. We can see that the adjusted R squared is very high. There's this phenomenon. There's only 205 data sets, and the more variables you add into a regression, by definition of linear regression, the higher the R squared will be. What we've talked about this quite a lot, and most people will be familiar and comfortable with this that I'm about to say, is that this means that about 92.4% of the variation in price is explained by all of these variables. The more variables you add in, even non-significant ones, the higher that number will get. But for so little data, the less generalizable this analysis probably will be. So it's just a thing. And the difference between the regular R squared and the multiple R squared is that the amount of data in different factors will be weighted. So it could sometimes be higher or lower, and it's about the same this time. Key takeaways. There's a good spread of residuals on the regression model. It says from this type of model, the R square is typically high. I would like to know what they mean by this type, maybe ones with loads and loads of predictors. The most important predictors it summarizes. Negative predictors, that's the positive ones and the negative ones. Interpretation, bigger, wider, heavier cars with larger engines and certain engine designs tend to cost more. Some body styles are on average cheaper. Rear engine layouts are associated with big price premiums. It mentions multicollinearity. There probably is quite a lot because there was a lot of correlation. So it flags a couple of them. I don't know if they're on the table. And how to use it for prediction. So we could probably ask it, but it's inviting us to do something else. So let's continue. Let's just ask it to create a nice scatter plot for something we're particularly interested in. I wish it would display it in line, and I hope it does. It's the second best that you can download the picture. giving us the ggplot. There we go. Okay, that's exactly what I expect. Okay, that's good. That's exactly what I expect. Price versus engine size. Some very, very tight relationship. That's probably got an R square of 0.8 by itself, but there are some weird things. It doesn't quite fit exactly, and it's probably doesn't fit for linear. Just commenting on that. And then let's see if it'll give us all that code right back in one box. They must have fixed this from some criticisms I was reading about prepping for this, that it must not have done that previously. Now they've fixed it so that it definitely does. Yeah, that's pretty good. All right, so I'm going to go back up here. I can just copy that. I'm going to open up my R script. It's just what I set up earlier. I only set up the header. Then I should just be able to paste all that code in. Just have a look at what it's given me. Now, we're at the end of our time, but if I go through this, this is quite nice. They've got really good comments already. I'm pretty impressed with this comment. It's variance inflation factor is one of the diagnostic tools using, especially when you're doing big multivariate regressions, that you would use if the variance inflation factor is too high for particular variables. That means it's correlated to other variables, and I know there will be some in this analysis. I did ask it to give good comments. It's got really nice sections. It hasn't named them in a way that we could do it, but that's an easy fix. If we wanted to make a clickable table of contents, we could do it ourselves. Yeah, I'm actually pretty impressed with what it did. A final thing I wanted to say before we finish this, this is nice. I saved the script and it's inviting me to install the package that I'm missing, ggalley. Um, I'll run this and step through the model myself after we break today. But a comment that I wanted to make here is that if people are interested in this, it's not statistics and math, but it's something that may be of interest to people to go through. Is that I've had the luxury since I was off work for a while of getting back and reading some literature, both in my own areas of research, but I became interested in some of the practical artificial intelligence research. And what the research is saying now about how these tools, these products are evolving is that we started off in a place where AI was a novelty, and we were learning how to use it, learning what it meant for our jobs, learning how to teach with it, learning what to do with it as a researcher, learning what to do with it to make your parish council newsletter, and everything in between. And then there came this huge time of hype. And what we read now is that it's going to replace jobs and do the work of 10 humans or something like that. Well, we're quite far from that, in my opinion, for a lot of things. What's probably going to happen, and the research reflects this. Not only does it reflect it over the past few years, but it predicts this going into the future, is that most current jobs that have productivity aspects to them, like doing data analysis, like writing text, like creating images. All of these will, in the quite near future, more and more ramp up to be a collaboration between a human that guides an analysis and an AI that can quickly do things that would take you a long time. And what I see for statistics, especially for people like us, for scientists, is that everyone's on a learning curve to get those programming skills, but also to get that knowledge of um, what analysis will extract the information you want. You know, if your data set is a sample of gold ore, you want to get the gold out, and you have to learn the best tool to do that. And the research would suggest, and I certainly agree, that a thing that AI does is it really removes the barrier of having to learn to code for a long time with a steep learning curve, but it doesn't really remove the barrier, not yet, um, for doing the kind of analyses that we publish in papers for that statistical knowledge. It's not as fluid for that. I do want to stress test this more. Probably will stress test it more in these meetings. But that's all I've got for today. I thought that was pretty fun, and I'm actually pretty impressed. I was prepared to be a little disappointed by Julius, but I'm more impressed than I thought it would be. The thing that I'm not impressed with Julius about is how stingy the free account is. So I will only have about 8 more prompts. Any comments or questions before we break? We're a little after time, and I do have to scoot off myself as usual. Any comments or questions? That's all I've got today. Thanks everybody for coming. I thought that was pretty fun, and I hope you did too. So